Another common type of problem is what's called a mixture problem. So these can be a little bit tricky. The idea is if we have X amount of a substance and it's dissolved in a solution of volume V, then its concentration is equal to X over V. And we're going to have to use this to deal with these. So let's look at an example of this type of problem. Let's suppose a certain juice company advertises their orange juice as naturally flavored, although it only contains 5% actual orange juice. A new federal regulation says that in order to be called natural, you must contain at least 10% orange juice in order to claim this natural. So we want to know how much of this pure orange juice must this manufacturer add to 900 gallons. So we have 900 gallons of the 5%, and we need to get it up to the new regulation of 10%. So let's start with what we know. So we're going to let X be the amount that we actually need to add to get up to standard. So right now I'm just going to write down information. This is the amount that we need to add. So 900 plus the amount that we added is going to be the new volume. In addition, if I take that 5% times the 900 gallons that we have, that gives me 45, which is how much orange juice is in the old vat. So that's how much of how much actual orange juice is in the original 900 gallons. The second one is pure orange juice, so we don't have to consider that. The concentration is just 100%. So the amount of orange juice in the mixture is going to be, well, we wanted 10% concentration times the volume, which is the 900 plus X. So this is what we actually need, but that should be how much we have plus how much we just added. So this gives me 90 plus 0.1X is equal to 45 plus X. Adding or subtracting 0.1 from both sides gives me 90 equal to 45 plus 0.9X. I can subtract 45 from both sides to get 45 equal to 0.9X. Dividing both sides by 0.9 gives me the X is 50. So I need to add 50 gallons of this new orange juice. Another common type of problem is the time it takes to do a job. So the idea of this is if it takes you 4 hours to perform a task, then in 1 hour you'll be a quarter of the way done. So it does assume an equal work, that you work equally over the amount of time. So let's say it takes John 4 hours to paint a house. Ben works a little slower, it takes him a little longer. And it takes him 6 hours. How long will it take them if they work together? So in general, the way this is set up is 1 over A plus 1 over B equal to 1 over C. In this case, it takes John 4 hours and Ben 6, so C is the amount it takes them together. 4 and 6 have a common denominator of 12, so I'm going to multiply through by 12C. 1/4 times 12 is 3. 1/6 times 12 is 2. And here I would just get 12. So 5C equal to 12. Dividing both sides by 5, we get that together it would take them 2.4 hours. The last problem I'm going to look at is a distance problem. D equal to RT. Distance is rate times time. So let's suppose Abby left her house at 1 o'clock and rode her bike at 12 miles per hour. When Mary showed up at her house at 1:10, Abby's roommate told her the direction that Abby had gone, and Mary went after her at 16 miles per hour. We want to know when they catch up to each other. For this one, I'm going to set up a table. So Abby, she's riding her distance, or rather, let's do R first. Her rate is 12 miles per hour. Her time, we'll say, is T. So R times T is 12T. Then Mary, her rate is 16, but her time is different. She has 10 minutes less. So 10 minutes is 1/6 of an hour, so T minus 1/6. Because she's been riding for 1/6 of an hour less time because she started 10 minutes later. If they're going to meet, we need these two things to be equal. So I'm going to go ahead and distribute this. 16T minus 16 over 6. I'll subtract 16T from both sides. That gives me 4T is equal to minus 8 over 3. So I went ahead and reduced this. Multiplying through by the denominator gives me 12T equal to negative 8. Dividing both sides by 12 by this should be a negative 4. So dividing both sides by negative 12 gives me 0.67 or 2/3. So 2/3 of an hour after 1 o'clock. 2/3 of an hour is 40 minutes, so they're going to meet at 1:40.